So in this lesson, we're going to talk about algebraic proofs. So we're going to use algebra to write kind of a two-column proof, and we're going to use some properties of equality to do that. So what is a two-column proof? Well, it's also called a formal proof, where we have numbered statements and corresponding reasons that show an argument in a logical order. So we've got some properties that you actually already know from algebra. You just didn't know that they were actually properties. So we have the addition property. So for example, if I were going to add the same thing to both sides, so if I had something like 10x minus 2 equals 12, then I would have 10x equals 14 after I would add 2 to both sides. So I'm adding the same thing to both sides of the equal sign. So for subtraction, it looks very, very similar. Let's say I had my 10x plus 2 equals 12. Then I would have 10x equals 10 because I would subtract my 2 from both sides. And if I had multiplication, that means I would have something like b over 3 is equal to 6. Make sure that's a b. There we go. And then I'm going to go ahead and multiply both sides by 3 to undo my division. And then I would get my b is 18. So that's when we use the multiplication property, multiply the same thing on both sides. And then we have our division property. So for example, if I had a 12x equals 36, then I would go ahead and divide both sides by the same number 12 to get x is 3. Substitution, or we'll get to in just a second, distributive, we know that one of distributing that number in front. So 3 times x minus 2 is going to be equal to 3x minus 6 when we distribute that 3 to each term inside the parentheses. Substitution is when we plug something in for something that's equivalent. So for example, if I had 2x and I know that x is equal to 4, then I would go ahead and plug that 4 back in, and it would be 2 times 4. I'm replacing the x with something I know is equivalent. That's substitution. So here's 3 new ones that you may not already know, but they're pretty easy to remember. Reflexive is like a reflection in the mirror. You're going to see yourself in the mirror. So it's not changing. It's just showing you what it is. So A is equal to A. Or if we talked about it in the aspect of segments, this segment AB is the same as segment AB. And then angles. Angle A is the same as angle A. And we do use that property occasionally. I know it seems kind of like a, well, duh, but we do use that property when kind of they're sharing sides. So symmetry or symmetric is kind of like the left side and then it's reflected to the right side. So it's kind of a mirror, or it's kind of a flipped image sort of. So instead of A equals B, then it's going to be B equals A. And then if we had AB equals CD, well then CD equals AB, kind of going that other direction. If we had angles, angle A equals angle B, well then angle B equals angle A. So that's the symmetric, kind of going the other direction. Lastly is called the transitive property. And transitive is kind of like, I always call it the choo-choo train, and then I'll give you another kind of analogy, but here's my transitive train. So that's big long train and we have plenty of cargo. And so it's kind of like, well, we just need the front and then we just need the back. We can kind of, if the middles are the same, then we can put the middle or the front and the end equal. So here's kind of a more relevant, let's say we're at the store and we really want some ice cream. So we want cookie dough ice cream. So if A represents Breyers and it's the same price as, I'm trying to think of all the different brands, as the Great Value brand, and then the Great Value brand is also the same price as, oh, what's that? Blue Bunny, then Blue Bunny is going to be the same price as our Breyers. So that's kind of what that is getting at with that transitive property. So if A is equal to B and B is also equal to C, well then this one has to be equal to this one because they're both equal to B. That's kind of what that's saying there. And it works for segments and it works for angles. So we will work with these properties quite a bit. Let's go ahead and see how we're going to use it when we solve our algebraic proofs down here. It will let me scroll. There we go. All right, so we're going to use these reasons, and you already kind of do it, like you know that this step has to come after this step in order to solve and get x alone. So we're just going to kind of identify from here to here what happened. Then from here to here, what happened? What did you do? Kind of the explanation of what property you used. So if we look here, looks like we're getting rid of our 8x, right? And how did we get rid of it? Subtraction. So we're going to put subtraction property of equality. I just use POE to represent property of equality. Now, how are we getting from here to here? Well, it looks like we're getting rid of this 9. And how do we get rid of that 9? Subtraction again. So yes, you can have the same property multiple times in a row. You don't just use them once. And then from here to here, what's happening? It looks like we got rid of our 4, which means we were dividing. So division property of equality. And we don't usually show our work because if you show your work, it's an additional step and then you would put division and then you'd have to put a next step of simplifying it and actually doing that. So we do kind of just leave our steps or our work out of there, but you can do it. It just is going to create twice as many steps because you do have to have a reason for every single statement you show. And then this last one, it looks like we're just flipping it around. Well, what is it when we flip it around? It is the symmetric property of equality. All right, let's take a look at another one. If you want to try this one on your own, go for it, or you can continue to follow along with me. The reason for the first one is always that it was given, because it doesn't just come from nowhere. It's given to us. Hey, here's your problem, or here's where to start. So that's given to us. So now we're going to see how do we go from here to here. What happened? Looks like they were using the 3 to distribute. So the distributive property of equality. All right, now how are we getting from here to here? Let's see what happened. Oh, they took this and they combined them together. Or they added them, but it's not the addition property because that means we'd have to do the same thing on this side and this didn't change. So when we're just combining like terms, you can put combine like terms or you can put simplify. Either is fine, but we didn't actually add on both sides. So we don't want to put addition. And then from here to here, it looks like we're getting rid of the minus 12 by adding 12. So we're going to go ahead and put addition, property of equality, and then dividing both sides by 10, division, POE. So a lot of times you're looking either above and below for that change, or you're looking from the left to the right. It depends on how it's written. So I want you to try and solve this one, putting your reasons here, and then check when you're ready. Since you're going to be distributing twice, you can actually go ahead and do that. Make sure you got given up here. All in one step because you are doing the distributive property just twice. So you can do both of them. If you did it one side and then you did the next side, you'd need distributive property and then distributive property. Again, each statement has to have a reason that corresponds, and you can kind of number them. I guess this would be 1, this would be 2. Next step, I'm going to go ahead and add my 2x over to here. So add 2x, add 2x. I'm going to put my work, but then I'm going to erase it because I don't want to have that additional step. Because right here, if I put this in here, I'd need to have the addition. Then I would have simplify because I'm showing my work here. It's a step or needs a reason. Okay. So I'm just going to put it to get, okay, 22x minus 36 equals negative 14. So I'm going to get rid of that addition work and I'm going to put addition, property of equality. Next step, I'm going to go ahead and add my 36. So if I add 36, that's going to give me 22. And so step 4 was the addition property again. This time I was adding that 36. And now I'm going to divide by 22. So x is going to equal 1. Division, property of equality. All right, here's another one for you to try. Very similar to that last one. 5 and 6 are just going to be, I'm going to go ahead and do them in the video here real quick, but they can be for later on. I'm not going to do those in class, just extra practice for a later date if you want it. So last one of our in-class notes is going to be this one. So it is given, and I'm going to go ahead and distribute. Watch your signs. So step 1, step 2, distributive property of equality. Because I'm using an equal sign, I'm going to use property of equality. All right. Then I'm going to go ahead and simplify, which is the same thing as combining like terms. So I'm going to go ahead and add those together. And then 10 and negative 28. So that's just simplifying. It's not actually the addition property. You can also put combine like terms. That's fine too. And then step 4, I'm going to use addition to add that 18. Addition, property of equality. And last step, I'm going to divide. Division, property of equality. Okay, so on these, if you want to try those, I'll go ahead and just put the answers in here so you have them to check with at a later time, like before the test. If you're just going back through notes and want to practice some extras, here you go. So go ahead and try them, and then I'll put the answers here for you to check with.